Okay, so we are going to have a look at the nth term for sequences. I'm going to start with A, and I've got 5, 8, 11 and 14. Now you could always have an easy question first, which is usually write down the next two terms. So if you're asked to write down the next two terms, the first thing you need to do is investigate that sequence and see what the pattern is. So what's the difference between 5 and 8? You are adding 3. Just check if that works again. What's the difference between 8 and 11? You're also adding 3. And then 11 to 14, you're also adding 3. So if I wanted the next two terms would be adding 3 to give me 17, and then adding 3 to give me 20. So if I wanted the next two terms, it would be 17 and 20. However, that is not the nth term. So the nth term just involves a little bit more effort, but you do need that first step anyway. So the first thing you do is work out what times table it acts like. So if we know it's going up in 3, so we've got add 3, add 3, add 3. Straight away, the only times table that we know that acts like that is the 3 times table. So it's like the 3 times table. This is in words. You may have saw your teacher explain like this. So it's like the 3 times table. Now that has a posh name in terms of nth term. The 3 times table is called 3n. So the 3 times table is called 3n, the 5 times table is called 5n, and the 11 times table would be called 11n. So whatever times table it is, acting like its posh name is the number with the an n in front of it, because that means 3 lots of that number, and we just use n for nth term. Now, once you know what times table it acts like, you need to ask yourself, well, is it the 3 times table? So look at the sequence, is that the 3 times table? So if you compare it to the 3 times table, I like to put the 3 times table above it so I can compare it. So the 3 times table is 3, 6, 9 and 12. So is the sequence I've been given the 3 times table? It's not. If I have a look at it, the first term in the sequence is 5. So what's the difference between the 3 times table and that number 5? So the difference is, how do you get from 3 to 5? You add on 2. Now, if I check the second term in the 3 times table is 6, but the second term in my sequence is 8. How do I get from 6 to 8? I add 2. Follow the process through. How do I get from 9 to 11? I add 2. Ignore the ice cream van in the background, and you can see that there is definitely a pattern going on there as well. So it's like the 3 times table, 3n, but we add 2. So to finish that off, the nth term would be called the 3n, which is the 3 times table, add 2, and that's its name. So you may think that was a little bit hard. I'm going to run through another example. Let me just move that. And then we'll have a look at slightly harder ones as well. So let's pick another one. The next one we're going to do is 9, 14, 19, and then 24. 9, 14, 19, 24. So I'm going to not do the next two terms. I'm just going to focus now on the nth term. So firstly, have a little look at it. What do we notice that it's going up in? So how do we get from 9 to 14? So you can count your fingers, 9, 10, 11, 12, 13, 14. That is definitely adding on 5. Check the next one, 14 to 19, 14, 15, 16, 17, 18, 19, adding 5, and so on, adding 5. Straight away, I now know if it's going up in 5, it's like the 5 times table. And the 5 times table has a posh name, 5n. So that's step 1. What times table does it act like? The next step is to compare it to the 5 times table. So the 5 times table, I'm going to write above the sequence. It's the 5 times table is 5, 10, 15, 20. Now the key here, which I should have said in the last part, is to make sure you start on the first number in the 5 times table. Not the one you fancy, not the one that's closest to it. Always start exactly where that times table starts. So our first number in the 5 times table is 5, but our first number in the sequence is 9. So it's definitely not the 5 times table, it's a little bit different. So how do you get from 5 to 9? Count it, you add on 4. Now, you don't assume that that's always the case. We need to check on a few before we can finally finish it off. The second term in the 5 times table is 10, but the second term in ours is 14, so that is also plus 4. And just check the final two. It's plus 4 to get from 15 to 19, and it's plus 4 to get from 20 to 24. So it's like the 5 times table, but it's got 4 added on. So its posh name, the nth term, is 5n plus 4. Now, there are slightly harder questions, and let me just see if I can get an example to demonstrate that. I'll just move back to that. Right then, so just at the top, one more example. We've got the sequence, which is 2, 7, 12, 17. So, same process, I'm going to speed it up slightly. Have a look at the difference. So the difference between 2 and 7 is 5, 7 and 12 is 5, and 12 and 17 is 5. So like the one we've just done, it goes up in 5, so it's definitely something to do with 5, and it's like the 5 times table. Now this is a bit where I'm going to slow down. We write the 5 times table above it. So like we've done in the last examples, we need to write down the 5 times table above it. So the 5 times table is 5, 10, 15, 20. Now this time we're looking at the 5 times table, which is 5, and actually the number in the sequence is now smaller than the actual 5 times table. So it isn't the 5 times table, it's actually less than it, and when it's less than it we take it off. What number do we take off 5 to get down to 2? 5, 4, 3, 2, we take off 3. Check it on the next term. 10 to 7, 10 minus 7, 10 down to 7, you're going to take off 3 again, so it's going to be take off 3, and so on. Take off 3, 15 minus 3 is 12, take off 3, 20 minus 3 is 17. So the only difference here is we know it's like the 5 times table, but it is less than it, it's less by 3, so we take off 3. So it's the exact same procedure. Find out what times table it acts like. If it's smaller than it, you just need to work out what you're taking off. And that's it.